Hey, everybody, and welcome to the February 2022 Gio Community Call. We're going to talk today about recent changes to Gio's text and editing stacks. And first up is Elias to talk about recent support for IME, as well as what that is. So take that away, Elias.
Yes. Okay. So up until recently, I'll just bring forth a modified version of the kitchen example and start not die camera, my presentation. And there you go. So if someone can't see my screen, please speak up. So this is a modified example, kitchen example. It's been modified to use the Noto font, which can represent, at least the full Noto font can represent, I believe, most, if not all, of Unicode code points. Because I'm going to use it to demonstrate the display and rendering of Japanese character. So, text input. If you have an editor or the like, there are two major parts of it. There is a part that actually displays text, such as the text you can see in the upper larger editor area up here. But there's maybe not as large a portion, but as the important second part of an editor is how do you input text? How do you, as the user of a Gio program or a program with an editor in it, actually enter text into the editable area? And for many or most of us in the community, we are probably used to a very simple input method, which is just clicking somewhere in the editor. I'm just going to use the smaller one just below the bigger one as an example. And as soon as you press a key, the corresponding character is displayed, is input in the content area of the editor, which can then display that content. And that is very simple. The interface to the operating system is equally simple. So it's more or less an character. You get a key press event for example, the character for the key C, and you get from the operating system the translated key, the key translated into a Unicode character. In this example, a lowercase c. It gets slightly more complicated if you press a modifier such as shift before you press another character. In this example, you get an uppercase C because the operating system notices that I had shift pressed while pressing C. But all this is very simple. You have key events translated more or less by a lookup table or similar into corresponding characters. It gets slightly more complicated with other languages, or if you want to use more modern input methods such as handwriting recognition, speech recognition, or many of the assistive technologies for people who may not be able to use a keyboard as many of us are. And for that area outside of just normal regular Western, if you so to speak, keyboard input, that is bundled under the acronym IME. I believe it stands for Input Method Editor. And Input Method Editor is simply something that can help the user compose text input, which is more complicated than just translating hardware key presses into characters. A very simple example is my native keyboard layout, which is Danish, which has accented characters such as E with an accent, and you enter that an accented E by first pressing the accent key, which then displays as an accent, and then the character that you want accented, for example, the E. And if you saw it, I would just repeat the action. I press the accent key and then the E. It actually replaced the accent character with an E, and that's a very simple example of an input method editor. You no longer merely input characters as a stream from the keyboard, you actually edit the existing characters already entered. So an accent is edited into an accented E. There's another example. If you have the tilde character, you can enter tilde and then an N and get the Spanish N. I forget the name for it. So that is slightly more advanced input method than just the raw US keyboard layout. An even more complex one, and maybe the more interesting for this demonstration, is input methods such as for Japanese. And I don't know what I'm writing, but I can still demonstrate, because I don't know Japanese, but I can still demonstrate that this is even more complicated than the Danish example. For Japanese input, at least in this mode, you press keys on the keyboard that then are then mapped into Japanese characters or characters combinations. So for this example, I just pressed A and S on my keyboard, and then suggestions appear. And this window is not rendered by TU. That's a system window. And you choose the suggestions that you want to input, and then you continue with more keys, which is then expanded into suggestions. You select suggestions and so on. So this is the input method. I would say this is the most complicated input method I've tried yet. But it demonstrates the fact that you can no longer, for more advanced input methods, you can no longer rely on just inputting runes or character to the editor field. There has to be a more advanced interface between the editor, in this example, it's this editor, and the system represented by this window and the characters that gives the editor. So more generally, this is represented by, in GU, by having snippets into an editor window. So in this example up here, there's a fairly large amount of text, and you don't want to just give all of that. You can't really realistically give all that to the system, especially if you consider edits that can come from your program, programmatic edits. So the interface between an editor, such as this one in GU, and the system, such as the macOS operating system I'm running, is best modeled as having a small view into the editor. And that's represented by the IO key package, that it has a snippet struct definition, which defines the range of the snippet and, of course, the content as a string. And you can specify, this is done for you in the editor implementation, but say you wanted to do another editor in GU, you would then use a snippet op. Let's see if I can find it down here, snippet op, which takes a tag that identifies the editor and a snippet that you want to present to the IME. And to get that range is not something that you necessarily want to control. The editor would more, in the current version of this implementation, the editor is given ranges that the IME is interested in by getting snippet events. So whenever an editor receives a snippet event, it knows, it tracks this range and gives and adds snippet ops whenever the content in this range changes. On the platform side, let's see if I can find, let's just duplicate this one. So that's one part. That's the editor part. That's the part that this widget has to implement to support the more advanced editing methods than just raw keyboard input in the US layout, or like, let's just see if we can find, it's called the app package. I'm not sure. Let's take the app package. Okay. Yeah, of course, that is a private implementation. Let's just use So for the driver side, yeah. So this is the interface given to the driver side. So a driver is the glue implementation between the general purpose window, app.window, and whatever platform that is currently running. So this is a driver. There's a driver for macOS, for Linux, for Windows and iOS, and so on. And those drivers, for those drivers, app window maintains a IME state, and that IME state contains an editor state, which is where is the current selection, where's the visually where's the caret, and the transform for the current editor field, and of course the snippet that I discussed before. So this is the entire state of the editor as seen by the driver, as seen by the operating system. So there's the snippet, the selection, and a few less minor details, which is the transform for that selection, sorry, the transform of this caret and the selection range. So, and the selection range is just what is the start and end of any selection. And if there's no selection, it's just an empty range where the start and end is the same and equal to the caret position here. And so by tracking the editor state in window and providing these methods where you can either replace text in a certain range with another text, you can edit the selection, and you can set the snippet range, and you can those three actually comprise the total, more or less the total interface to the driver, so that in turn it is very easy to implement the IME part, the platform-specific IME part. And to give you an example of this, as you can see, the input method needs to know what has been entered. Let's just switch to a more complicated one. It needs to know that you have entered AS in this example, and when you select one of the suggestions, it needs to be able to select all of it. So it needs to manipulate what is the current snippet or the content of the current snippet, and it needs to manipulate the selection. And that's what the drivers can do through set editor selection, set editor snippet, which is sets the range of the snippet, and finally replace, which actually inserts text. And that is needed because sometimes if you switch between suggestions, it needs to actually replace text and not just insert new text. And to give you an example or feel of what the difficulty of implementing a platform, I've taken the Windows implementation of the platform, which is just which is the Windows specific parts of binding the Windows IME implementation with this editor interface in app.window. And as you can see, it is actually not that much code. There's an import, there's a different, the interesting part is this, the IME is implemented through 3 window messages coming from the system's start of the composition. Composition is simply that an IME session is starting, and if it had to be the macOS, this is where the window, the IME from window from the system pops up. There's an IME composition, which simply means that the user has done something to the he's changed the composition string, more or less, and there's end composition, which simply says we're done with editing whatever the user's trying to insert. So there's start composition, which is more or less when the window appears, composition message, which is here, which is what changes to the content of the window, and end composition when the user is done editing. And of course, there's a little there's a communication the other way, which is editor state change, which is what app's window calls to the driver when something other than the IME method changes the content of the window. And that's, of course, if you are editing something here and suddenly you in a programmatic way edits changes the editor content, then the IME has to react. And usually it reacts by just closing the window. That's what you do here by saying you notify the IME, the system IME, and you ask it to cancel the composition. I think that's about it. Yeah. So obviously, the macOS implementation looks slightly different because macOS IME is implemented in a macOS-like way. And finally, there's an implementation for Android as well, which is a bit more complicated than this because IME on Android is more detailed. On Android, the IME from the system can ask for what is the existing content of the editor. So, for example, if you start here on Android, you can actually get suggestions based on the existing text, even in, say, an American or a Danish keyboard layout of the software, because the Android keyboard also wants to provide auto-completion and spelling corrections and so on. So that's where the snippet actually gets really used on Android, because it asks for maybe, let's just say, a range like this around the selection. So it can take that snippet of text and provide context-specific auto suggestions. Yeah, so I mentioned there's macOS, Windows, and Android implementation for this. I hope that someone will implement support for Linux and iOS. I guess that's about it. I don't know if IME support can be implemented in the browser, but if so, that would also be a nice thing to have. Yeah, I think that's about it.
Okay. Well, does anyone have questions about that?
When I press you ask whether it's possible to revert the behavior to what the browser does. Okay. Not at the moment. Is there a reason you don't want this behavior? Of course, there's a reason. I'd like to know what is. I would have guessed that this is a good experience for the user, that they can actually see the accent that they have pressed before entering the full composed text. Never showed the accent that I use. All of them. You mean all inputs from in Gio or all the inputs in general? General. Okay. Is this in Windows or is it everywhere? It happens like this. Because I would guess that this, this behavior of having the accents showing before entering the full character is very much platform specific. So I would guess if the behavior in your browser, is IME, uses the same IME implementation or interface that Gio now does. So I would guess that if you don't see accents in your browser, you shouldn't be seeing them in Gio either. If that makes sense. So to be clear, I'm not doing anything for the actions to show up. I'm simply accepting whatever comes from the IME interface on the platform. So when the platform says, I would like to insert an accent here, it's just inserted, and then that snippet is sort of saved in app.window. And when it comes back a second later, because I press the E and says, I would like to replace the snippet that you saved with an accented E. App window just does that and sends the message back to the editor, which then does the actual replacement of that. Before, the character was just an accent, and now it's an accented E. So there's no special. What I'm trying to say is there's no special treatment that you see. All of the behaviors you saw in the Japanese input and the Danish input is specific to the behavior of macOS and that keyboard input. Do you have any other questions?
I've noticed kind of an interesting corner case, or I don't know. When I've used Android apps built from Gio after IME was implemented, at the beginning of text composition, it suggests lowercase words, but other applications suggest words with the first letter capitalized. So I'm curious what we're doing differently, I guess, there.
It's very likely that Lucas actually knows more about this than I do. But I can say that the IME implementation on Android is relatively basic. The important stuff is there. There's the communication of the snippet. There's the synchronization of the snippet, the current editing snippet, between app window editor and the system IME, which is by far the most important. But there's extra features in Android. For example, you can specify what is the expected content of an editor. And I believe we have something like that implemented by Lucas. But there's also a setting for whether words or sentences or nothing at all should be capitalized. So that's sort of, I don't know if that's I don't remember if that's a subtype of the main type, which is maybe there's, for example, general text, there's phone numbers, there's all sorts of things. And I don't know whether this capitalization mode is a subtype or some other setting. So it's simply, I would say it's simply missing from the IME implementation. And before, where we didn't have IME at all, it wasn't really an issue because on Android, we just told the software keyboard that we were a dumb editor, which made most, but not all software keyboards behave as you would do with a physical keyboard, where each key you entered or pressed or touched, tapped, would then just appear as a rune, and that's it. So all this thing about all these extra features, such as what is the expected content, what is the capitalization mode, and so on, didn't even appear as a concern in the interface between the keyboard and the editor. So I would say this. I have noticed the same thing, and I'm not that surprised that it doesn't work yet. But I would also not be surprised if the work to enable behavior such as that would probably be not that much extra work.
Okay. Any other questions? Well then, I'll talk about complex scripts. So you're going to see a lot of the kitchen example today. This is a modified kitchen example where I have run all of the text through Google Translate. So bear in mind, especially if you're watching this later and you can actually read Arabic, which I cannot, this is probably a little bit gibberish. That being said, here we have Gio displaying Arabic text. And there's actually a lot going on under the hood in order to facilitate this. So we have our good old multi-line editor. And you'll notice all the text is right aligned because that's the default in right to left languages. And I can select text. That's not super surprising. But for people who predominantly use left to right languages, the multi-line text selection might be surprising. When I drag down, you see that instead of selecting from where I was to what we think of in left to right languages as the end of the line, and then wrapping around and selecting to where I was, we go the other way because this is the end of the first line over here on the left. So it took a while for me to be able to even think about this very clearly. It was weird at first, but after the patch set that I posted Saturday, you can do this. Now those patches are still under review, and some things are definitely going to change. But today I want to talk about essentially what's going on in those patches, what I spent the last 4 months doing, and how it's going to impact you as potential application developers with Gio. You'll also notice that in here there are these stretches of tofu, which is the font terminology for text that the font in use did not have a glyph for. And that's because this passage of text contains some proper nouns. And when I fed them through Google Translate, it just left them in the original language. And this font does not contain glyphs for Latin languages. So it shows you nothing. And we'll talk about that shortly. But anyway, the bigger point is we've got Arabic all over the place. Now let's look at what I had to do to this application to make that happen. Other than, okay. Right, it's not in Git. Let me make this much more bigger. So the biggest changes, other than some imports, are the introduction of a new font collection. So this is like when you use gofont.collection to get a collection, except here I'm parsing the font data for Noto Sans Arabic Regular, which is one of the Noto fonts like Elias was using. And I've defined this thing that is currently called a lang config. That name is going to change, and where it is within Gio is going to change. But this describes the language of text in the interface. And it's got 3 components. Language is the name of, I mean, this sounds stupid and redundant, but the name of the language in use. And the reason we need this is because multiple languages share Unicode code points, but those code points are expected to be displayed differently in some languages than others. Then there's the script, and the script here seems super redundant, right? So I already said, hey, this is a language with the standardized code AR, that's Arabic. So why this? Script is not the same idea as language. A script is a writing system. And there are lots of languages where you can write the language in multiple different writing systems with totally different rules about how you position characters and how you compose characters and how you read them. So without this script information, we are unable to correctly display a string of text. And then finally, the direction. So that is, the predominant flow direction of text, which for Arabic is right to left. So what I did with this lang config is whenever I made a theme, I just attached it to that theme. And then the only other changes I made to this code were translating all of these strings. And of course, when we get to the long text at the bottom, the diff is huge. This is what unshaped or incorrectly rendered Arabic looks like. So if we take a second to look at these glyphs, my terminal emulator is not correctly, well, actually, I'm not sure if it's the terminal emulator or if it's diff's fault, but either way, these glyphs are not being recognized as a right to left string. So they are instead, one at a time in the order their code points appear within the string, showing us an Arabic glyph. So you'll notice that they're a lot more disconnected than the text that we were seeing earlier, because Arabic is full of characters that, when placed adjacent to one another, combine. But they can't do that in this mode, or when they're being displayed incorrectly. And so right now, if you were to supply Gio with an Arabic font using the main branch, and you put in Arabic text, this is what you would see. Because Gio does not, in the main branch, have a shaper that can handle this. Okay, so the changes are actually really minimal. We basically just chose a different font and then configured the language. So let's talk about how this all works. So my work has been to, actually, I'm going to approach this from this side. My work has been to teach our text package about more complex shaping options. And I do that by and large by using this package called shaping in the typesetting repository of GoText. That is where I and some other gophers have been working to build a pure Go text shaping stack that the entire ecosystem can benefit from. And so there's a lot of work being done in there. But for our purposes, the text package defines the interface we have from Gio with our text shaper. And I tried to make as few changes as I could, or as I could get away with. So our text shaper has always returned us these layouts, which are descriptions of the glyphs. So you feed the text shaper Unicode data, runes, and then the text shaper feeds you back lines of text that are properly line wrapped and other things. And the glyphs are the actual data about which font symbols are being used in that particular line at each position. I mentioned earlier that in more complex languages like Arabic, adjacent characters can fuse together. And sometimes the font glyphs actually are designed to connect to each other, or sometimes the font has a single totally separate glyph that represents the combination of several adjacent glyphs. So Harfbuzz, which is the underlying shaper that we use, has this concept of a glyph cluster. And a glyph cluster represents a arbitrary length sequence of glyphs that are not meant to be divided. And so this metadata here kind of gives us an easy way to look at all of the clusters within a line. Offsets tells us about where within the overall document of text that was shaped we are in terms of both runes and the offset of those runes. And then, of course, direction. So if we look at the engine, these types are probably not going to be exported when this work lands, but as it stands right now, text has this type called engine, which does the shaping for an entire document. So you provided a font and pixels per M value that helps it scale the font, the width of the area in which you want the text to go, that language config that we looked at earlier, and a rune reader that will give it text. And it returns to you some shaped lines of text. So what document actually does is pretty simple. It just reads your text looking for the boundary of paragraphs. And when it finds the boundary of a paragraph, it calls this function to shape paragraphs, and then does some offset math and returns it to you. So the more interesting work happens not here. Paragraph converts all of this input into a type called shaping.input. Shaping.input is defined by the typesetting shaping package that I mentioned earlier. So it describes your text to our shaping API, and then we invoke the shaping API, and we get out this shaping.output, which describes the resulting sequence of glyphs. But an important thing to know about text shaping is the text shaper itself does not care at all about width constraints. That's not its job. So you feed it a bunch of runes and it feeds you back a single extremely long line of text. And then it is your job to make that line of text fit inside of whatever space you have. There's a lot of different strategies for doing that. Some of them involve like breaking it up and reshaping parts of it. But right now we're trying to do the simplest thing we can, which is essentially look for legal places within this text that Unicode says, yeah, the boundaries between these characters are a safe place to break a line. And then line wrap. So our line wrapper is honestly where I spent several weeks, maybe even a month, because I was trying to make this work equally well when it was line wrapping left to right and right to left and having to solve for some of the space constraints in there and breaking apart the line with all of this index math. Its algorithm is basically a greedy algorithm. It says, okay, for every line break opportunity, I will, if I haven't done any line breaking, I will say at least the first segment of the line should stay. And then I'll iteratively try each segment and see, can it fit? And if it can, I'll keep that one and keep going until it doesn't fit anymore. then I'll break it at that location and start the process over on the next line of text. So that's the bulk of my work that's visible within Gio, except for making the editor understand this. But let's talk about typesetting. So this is that repo that I mentioned. And these are the 4 people who've mostly been working on it. Stuart and Andy are both from the Fine, FYNE.io GUI toolkit, and Benoit is just an enthusiast for text layout. So the typesetting package provides these 3 dye, font, and language, and those are all kind of metadata about text. And then shaping, which is where everything actually happens. So shaping is the thing that consumes all of your text config or lang config, whoops, and converts it into font runes or font glyphs. And the way we do that, to shape a thing, okay. So to kind of pick up where I think we were cut off, the typesetting package in its shaping surfaces this shape function. And all this does is convert from shaping's own input type into the kind of arcane harfbuzz buffer, which is how harfbuzz thinks about shaping text. So we populate all these different fields and set the scale, and then this is where all the magic happens, this one shape call. So this is where harfbuzz transforms our Unicode data according to the language, font, and script and direction that we provided into just a bunch of glyphs. And then we pull out a bunch of glyph information from harfbuzz and return it. So you could think about this as a glorified wrapper package that makes harfbuzz easier to work with. So what is harfbuzz? Well, harfbuzz, actually, I guess I can pull up their own. I've spent a fair bit of time here. Harfbuzz is an open source text shaping engine used by all the major open source browsers like Chrome and Firefox, and honestly, pretty much every open source thing that shows text. Like if you're on Linux, every desktop environment pretty much uses Pango, which uses harfbuzz to display text. So harfbuzz is this big C++ project. It's very complicated. It's been under active development for like 20 years. It's a big deal. And we were really reluctant when we tried to tackle and when we thought about tackling the complex script problem. We were really reluctant to use harfbuzz because it would mean linking against a C++ project from a Gio app, and we really didn't want to do that. But totally independent from us, a gopher just ported the whole thing by hand to Go. So Benoit decided that he wanted a pure Go harfbuzz implementation, and he ported it all, and he ported the tests, and it passes the tests. And I mean, I've used it a fair bit now, and it works. So thanks to Benoit's colossal project, we can do high quality text shaping in pure Go, which simplifies the build process of stuff using it. And basically, we can't thank Benoit enough for doing that. So he did that. We built the shaper to make it easier to use. And we intend to put some other functionality here. Like that line wrapping logic I was showing earlier is intended to eventually live here instead. And then, you know, on the Gio side, we consume this easier, higher level API. So let's talk about what my work does not yet do. As you saw when I was showing the Arabic kitchen example, if the font it's using doesn't support a glyph, it just shows rectangles, shows tofu. And that's because font fallback is not currently supported. Harfbuzz, well, that's not Harfbuzz's job. Harfbuzz assumes that you've given it the font you wanted to use and that font can shape all the characters. And it will give you tofu characters if that turns out not to be true. So we need to implement the font support testing and fallback ourselves. So that's something that's ongoing within the typesetting repository in GoText. Benoit, again, has done a lot of work to build out helpers for testing font support. But there'll be a little work to integrate that correctly within Gio. So that's not going to be part of the first patch set for complex script support. There's also the question of font loading, right? So right now, many Gio applications just embed the GoFont package. So we're literally embedding kilobytes of binary TTF font data into the executable. That's not ideal. Makes the app bigger than it needs to be. But if you think about writing an internationalized app where you're potentially in one of dozens of languages, the cost of embedding a font for each one gets prohibitively high very fast. So we want to be able to load system fonts. You know, whatever the user already has on their laptop presumably is going to support the language that they use. And so there's also work ongoing in the typesetting font package for querying kind of a list of the system fonts and loading them. But we're trying to work through both the API and also some kind of performance stuff, because we don't want to scan potentially thousands of fonts on the system looking for the right one and block application startup for multiple seconds while we do it. So there's work ongoing to resolve that. And then there's the question of how do Gio apps know what language to use? So Lucas has already implemented the pref package in GioX, which kind of shows us how to find the system language. We will probably need to take that and plumb it into core, or some part of it into core, so that your application at startup knows the locale of the current system. And then that information can be more or less automatically plumbed through to the text shaper. So the desired end result, not of the current patch set, but of the feature, is that you'd be able to write a Gio app and provide translations for a bunch of different languages. And then when your app starts up on anybody's computer, it finds their system locale, figures out the language, and uses that to select the appropriate translations. Then finds the appropriate system font to display that language. And then when your app starts rendering text, it uses that system font with fallback mechanisms in place so that if you have like mixed language text, like Arabic that contains English, it will fall back appropriately to fonts that support the other glyphs. But when my work lands, you will have to manually instruct Gio to use whichever language you want. Yeah. Are there questions? Okay. Well, I think we can end the recorded talk here. So thanks for attending and listening.